Welcome. In this video, we'll be talking about data centers. So what are data centers? Data centers include a room or a building and IT equipment such as servers, networking gear, and storage systems, as well as facilities that allow data centers to securely house, provide power, and cool IT equipment. So let's look at some of the typical data center components. So say given a particular area that's going to be designed as a data center, uh, most data centers contain a raised floor. So the raised floor allows for routing of power and cooling equipment below the floor into individual areas of the data center. And we are going to have this data center partitioned into multiple areas. We are going to have a main room that is going to contain individual racks or cabinets that contain the actual server and networking infrastructure. So these are the racks that will actually house the individual servers in the data center. Along with that, we will need power distribution units that will be used to send power to these individual racks. And again, the actual cabling is typically done below the raised floor. We'll also need electrical switch gear that'll be used to provide power to the power distribution units. And most data centers will have some form of UPS to provide redundant power in case of a power failure. And the UPS is just used to provide power for a few minutes until the backup generators can come online. And the backup generators obviously require some sort of fuel. Most backup generators in data centers are, designed to use diesel fuel, for example. Now, so this covers the compute and power requirements of the data center. Now we can talk about some of the cooling components that are used in the data center. So typical data centers are kept cool using computer room air conditioners or CRACs, and these units will feed cold air into these individual racks and bays of racks. And sometimes the cooling is done directly into the room, but more specialized systems will actually feed the air into the individual racks, either under the raised floor or through some other means. The CRACs are fed through heating, ventilation, and air conditioning chiller pumps. And there will be some sort of mechanism by which the heat generated from inside the data center is sent outside through a rejection mechanism, basically an exhaust for all of the heat that's generated inside the data center. So let's look at some of the data center trends. Now, data centers are getting really big. So typical data centers today now can consist of anywhere between tens to hundreds of thousands of servers. Companies, especially internet service companies, are scaling out to multiple data centers globally. Companies such as Amazon, Google, Microsoft, and Facebook have multiple data centers located in different regions of the globe in order to service their different global clientele. The servers themselves are having much faster processors, more memory, and more storage. And typically, companies have to keep refreshing their servers in order to gain in terms of performance cost, but also in many cases reduce their power consumption by utilizing more efficient servers. And there's now increased use of virtualization and cloud technologies to manage all of these systems in data centers. Now, the image that I'm showing you is a representation of the global data center traffic as collected by Cisco. And there is an increasing trend towards more and more traffic originating or destined to cloud data centers as opposed to traditional data centers. And that is only increasing every year. And there are many companies that actually are using systems known as containerized systems. So these are entire shipping containers that are pre-installed with servers, power, and cooling equipment. And these allow companies to expand data center facilities in a modular fashion. So they just bring a container and then plug in power and networking and some sort of cooling system or maybe some vents, and these containers themselves contain all of the required equipment to keep a bunch of servers running. So let's look at some of the energy trends in data centers. Over the past couple of years, compute and storage densities have been increasing considerably per rack. Now, the images that you're seeing are of the average watts consumed per square feet, plotted from 2003 to 2010, and the average kilowatt per rack. And as you can see, these are climbing, quite significantly over the last couple of years. So the increase in average power per rack and per square feet is directly tied to the increase in compute and storage densities, and this leads to more powerful cooling systems and solutions that are required to keep these racks of servers cool and within operational parameters. We can also look at some of the business trends in data centers. So earlier, data centers were quite famous for the co-location business, and this is still quite significant for many companies. So in the co-location model, a data center basically provides the physical space, power, cooling, and connectivity options. You as a client can basically rent out racks or physical space from the data center, and you can install your own servers and basically pay for the data center services such as the real estate, power, and cooling. One of the other services that is available is web hosting, and web hosting service provider will have servers available for clients, but in a non-virtualized fashion. What they do is they sell sort of these server space and give you server accounts for you to remotely log into their servers, and you can set up your sort of web applications and set up the required databases necessary. So it would be you and a couple of other clients that are sharing a particular installation of a particular operating system on some servers that are hosted in a data center. Now the trend is moving swiftly towards cloud services, and as we've explained before in the course, it's basically the idea of a cloud service provider that provides virtualized computing resources, compute, network, and storage to clients, along with some sort of billing mechanism that allows to charge customers on a per hour or per month or per year basis.